In this demonstration, I would like to share with you how Robotis, Plus Task and Manager, how they do handle communication programming. So first, on the PC side, coming out from a USB port, I have USB to Dynamixo, a ZIG to Serial module here, and a ZIG 100. On the controller side, you can see I'm using a 904 OpenCM 9.04-C here for communication to the controller board. I'm using a Macchi Zigbee ZIG100 right here for this right now. In this demonstration, the way I'm using 4 servo. This is servo number 1, ID number 1 is used to represent the thousands, the digits for the thousands. Servo number 2, ID 2, we use to represent the digit on the hundreds. Of course, this one next to it will be the one that the digit correspond to the tens, and this one would be the digit that correspond to the ones. Okay. So let's switch over to the code a little bit. Let's talk about it. So first, the program start, they call initialize, and essentially call initialize is just having a for loop. ID go from 1 to 4. You can see here. Address number 11 essentially set it up to control mode of the mode 1. That means it's wheel mode essentially. And then set the speed to medium speed 512. And then we go immediately into an endless loop. And it has a wait while. As long as you don't send any data remotely or through the message, this flag will be false. Eventually you send something, and then this flag will become true. Of course, that time it kick out of the wait while loop. Whatever the data is, remote control ISP will pick it up, same to parameter called data. And then because I want to strip out the digit that correspond to the thousands, so whatever the data is, I divide by 1,000. So 1,000 here, the parameter will be the digit correspond to the 1,000 position. So I just print it out. And because this one, I want to manipulate the servo number 1 over here. So I said ID equal to 1. If 1,000, the parameter 1,000 is bigger than 0, that means it has some kind of valid values. And then you loop for it. And you loop basically as many times as the parameter 1,000 require you to do. And it does its call motors. And call motors just make it go at 512 and have a wait time for a second. Call wait. And call wait just set up the timer for that amount of time, which is about 1 second here, and wait until the time's out. So this one essentially, these 3 statements just tell to turn clockwise at half speed for a second. And then this one here tell it to go to turn it off, but wait here also for half a second. So every time you call the motor, it will turn the motor, the specific motor, which is right now we were talking about the IT equal 1, and it will turn as many times as the digit thousands represent, and essentially stop for half a second before it gets out. Let's say you didn't, if the data coming in doesn't have 1,000 digit, it will trigger this else, and we'll call LED, and call LED. Just go that, set it to essentially set the LED to color 7, which is a white. Essentially turn it on for half a second, and then turn it off. Wait for half a second there too also. All right. So basically, this situation here, we take care of the thousands digit, and then this group of data essentially can take care of the finding out what is the hundreds, the digits that correspond to the hundreds. So whatever 1,000 we had before, multiply 1,000, subtract it from the original data, you get T2. So basically, we get rid of everything that is in the thousands. And then T2 divided by 100 will give you the digit that corresponds to the hundreds. And print out hundreds, and 100 corresponds to ID2, which is this guy. So therefore, we have ID equal 2. Basically, the trick is the same thing. Turn the motor. There's how many times the hundreds, the parameter hundreds require. If there is no hundreds data, well, just turn on the white LED for half a second, turn it off for half a second. Next, of course, how to get to find to the tens. So whatever hundreds was, multiply 100, give you T3. T2 was here, that have the hundreds data in it, subtract it, and then T4, divide by 10, you get the digits for the tens. So print out the tens. This will correspond to ID3, which is this guy. So, and then it's supposed to turn it on so many times as a tens parameter require. If not, well, you call LED again. I think by the time this time you get the idea. So this is the code to get to find the tens. Subtract from T4, give you the units, the ones, and then print with line the ones, and set the ID4, and do your call the motor or call the LED depending. And then finally, whatever the data, original data the controller received, use remote.txt to send it back out again. The reason I want to show you this because sending the data with print and print line is very different from using remote.txt. You will see it when we run the code. And then, so print with line data, just print it again out on the output monitor here for you to see later. And you can see the difference between you work on TXT something and print some data. It's very different in communication programming with the Robotis system. All right, ready to go. So we have COM6 for my ZigBee here, and 9 and 10 happen to be for BT210, and then we'll show you that later. So we have the right controller, everything is set. So let's download it. Okay. And because this is CM904C, all the open CM904, you have to turn everything off. After you load the program, turn it back on again so to make sure the program is running. Now I can go to view output of programs. So I'm going to pop, or you can turn it off from here. And you turn it on here. Either way, it will work. Okay. So we're pretty much set. So I'm going to push U, which is essentially correspond to the number 1 really that are being sent out. See? Okay. So that thing a little bit fast there, maybe you didn't see it. So whenever you push using the virtual RC100 or using the real RC100, anytime you push down a key, like example, I'm going to push down next. That's equivalent to number 2 being sent out. So 2 being sent out. So therefore, you're going to see that this one will flash LED because there's no thousands digit, there's no hundreds digit, there's no 10th digit. And then this one will turn so many times. So if I push D, this servo, you're going to see it turn 2 times. The other one just flashed the LED. Okay. But then you also notice, so it's going to show the next time when I push D, it's going to print out 0, 0, 0, 2. And then in the code, it's supposed to send out the TXD1, you see it, the windows here, the program output monitor window printed something called U. Because what it does is when it sends out TXD, it prepares the data in a very special packet. And the output monitor expects just a plain number, like to RS-232, so it couldn't print it out. So it print the best it can, which is U. So when you, this one here is a print line, the data, which is, you can see it matches whatever I put in. Also, you notice another thing too. What is this 0, 0? I didn't put 0, 0. This is a feature or peculiarity, it depends on how you want to look at it, of the virtual RC100 and also of the real RC100. Anytime that you release a button, the little controller on the remote control will send out 0 signal. Okay, so this will be handy when you do remote control, because you need to know when somebody release the button. So this 0, 0 here just means that it released a button. Okay, and we're ready now. I'm going to push D. So keep an eye on it. Push D. Flashes, flashes, flashes. 1, 2 times. And then flashes 0 correspond to the release of the button. Okay. Let's push 5, which corresponds essentially to 256. 2, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay, I think you got the idea now. And then it just flashes because it got the 0. All right, so that is, well, you can use that to test virtual RC100 or the real RC100. They also, the manager tool. The manager tool also has something called ZIG2 serial management, and actually you can send command and stuff like that through it too. So you choose the right COM port, click on ZIG2 serial management. You check that it's going through COM6, which was the same thing, which essentially the ZigBee here. So you can see it's interesting. Let me send one again through here. See it flashes, and that one will turn on 1 time. Let me send 2. But you notice that it didn't flash the 0, 0. So when you have ZIG2 serial and you send data, it does not send the 0 when you release the button. You see it received the data. This one sent in the proper data packet format, and this is received the data in proper packet format. So it doesn't print that U at all. Okay, let's have a look at 2. Flashes, 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 2 times. And then it received data, it sent back properly. Okay, let's try 1023 then. We're gonna make this one turn 1 time. This one LED only flashes. We're gonna make this one turn 2 times. We're gonna make this one turn 3 times. 1 time, flashes, 1, 2, 1, 2, 3. Okay. Next, I'm just gonna turn this off and switch to BT210 just to show you that it's working really. So it will be ZigBee or BT210 is fine. So BT210, you see Bluetooth, so flash is blue. You just leave everything there. Okay, so let's see. I think BT210 is going to be COM10 for me here. Let's see, I'm on the right one or not. We'll find out. Download. Looking good. You output the program. But you notice with Bluetooth, everything always slow. And with Bluetooth, you definitely should turn it off here. Turn it on, leave for a while to get the program kicking, and get the PC have time to connect to the Bluetooth part. If not, you never know. And then you click on remote virtual again, and let's do the same thing. It pop a message. Didn't like that one, so let's try COM9 port and see. Did not like that either. Let's see. COM10. Okay. Let's try again. See, so Bluetooth is very finicky. Communication is always very slow. So I really have never liked Bluetooth, and the last few months I've been able to do Bluetooth and give me all kind of problem all the time. But now the LED is solid, so it's communicating properly now. Should work now. Here we go. Okay, and then okay. You see the problem here? I push it only one time. So to pick it up twice, and also it does not clear out the 0. So this shows clearly that the implementation on Bluetooth doesn't clear the buffer properly. Let me try D again. I'm going to push only one time. I'm going to push on keyboard arrow down also, it does the same thing. Interesting. Used to be able to click on keyboard, but it doesn't do it now. All right, so let's do here. 2, it sent the data over 2 correctly. And 2, it should see 0. Okay, so this time around, it does send it clearly. Let's try right. So it should be 8 times. 4, 5, 6, 7, and then all 0 L doing that. Good. Finally behave properly. You notice the U, of course, as usual, have problems when it TXT out the data. All right. So lesson is COM10 here. And if you're using Zigbee, Bluetooth, we had to watch out waiting until everything had to be connected. So let me put back on COM10 here. Let me go Zigbee to serial. Okay, you notice it's solid now. So this time it connects a lot faster. So let's use 3. Send out 3 flashes, 3 times. 2, 3. Perfect. Okay. So now let's send 2048. Here we go. 1 time, 2 times, flashes because it's 0. 2 times, 3 times, 4 times. That should be 8. 1, 2, 3, 4, 5, 6, 7, 8. Bingo.